Hey, also, in this video, we're still looking at trinomials where the leading coefficient isn't 1, but this time we're going to look at a version when the numbers are really, really hard to work with. So if you remember from the last video, the first step we would do is go 15, we would go a times c, so 15 times negative 48, and that gets us negative 720, which is a gigantic number, and even worse, because of that 48, like almost everything will divide into the 720. There are a gazillion pairs that will make 720. Not a gazillion, but there's a lot. And so this video is going to be how to be a little bit smarter than the 720 and figure out what's a waste of time and what's a little bit more direct method. In the previous video and in lots of videos, if you just pull one up online, they'll start going 1 and 720, 2 and 360. And let me just show you what that looks like. I wrote them out over here. These are all the pairs that don't matter that I can eliminate right off of the bat, and I'll show you how come in a second. And then this list would go on and on forever. And so this is what we don't want to do, is waste our time with that. So the way that we do want to do this, get that scooted back over, is to look and think about what we need the numbers to do, and that is we need them to multiply to be negative 720 and add to be 22. So let's see where we are right here with the 15 and the 48. And in this case, because this is a negative and this middle term is a positive, like we saw in the previous section where they were nice and this was just a 1 in front, that means one of our numbers is negative, one of them is positive, and we're really looking for the space in between the numbers. So if I was thinking of 15s and 48s, with one of those being negative, and it's going to end up being the smaller of the two numbers that will be the negative, the difference between those is 15 minus, that'd be 33. And so we're looking for 22, so we're getting closer with that 33, but we're not quite there. So the next thing I would do is, if you try 12, just to eliminate it, it would be 12 and 60, and 12 and 60 is getting farther apart. I need my numbers to get closer together, so that means I need to go up from the 15, not down. So then I would grab out a calculator and go, let's see, I bet 16 goes in, and if I do that, 16 goes in 45 times. And then those two numbers would be 29 apart, so I am getting closer. I need it to be 22. I don't think 17 is going to work because it's a prime, so I would try 18 next. And if you try going 720 divided by 18, that one comes out to 40. And those two numbers are 22 apart, and you have your numbers. So don't mess around making the giant list of things that can't possibly work, because here, right, the numbers were 719 apart. That is like way far. Same thing here. These would be, 358 apart. So all of this is a waste of your time. Find something that is close and then just work from that point, a little up or a little down, depending on, again, if I tried the 12 and the 60 instead of from the 15, I would see I was getting farther apart rather than closer together. So I could get that in 3 tries just by being a little strategic about the numbers I'm picking. Once I have that, okay, cool, so now we can do either AC or magic method, and again, I'll show both in this video just because people may have a preference for one or the other. So let's do which we have a positive 20 is 2, so that means our 18 will be the negative. And again, it doesn't matter which order you put these in, you're going to get the same result. If one seems easier, which to me, having that be positive and not have to factor in negative seemed a little easier. So just rewriting that, 22 is minus 18 plus 40. And then I look at those first two terms, and it looks like the greatest common factor there is going to be a 3 and an x. So we'll take out a 3x, and that's going to leave me a 5x. And 3 goes in 18 6 times. That'll be negative because of the sign there. And then this is where it's kind of nice to know where you're trying to get to. So 5x minus 6. And here it looks like I need to get this factor down to a 5, so that means I'll be pulling an 8 out of there. Just to check myself, 8 times 5, 40, 8 times negative 6, negative 48. And we have it. And that's like a really hard factoring problem. 3x plus 8 made not that bad, again, if you're just a little strategic about how you approach finding those two numbers. If I had done this by magic method, so that would look like 15x, and my numbers were minus 18, and then here's that extra 15, and that will be plus 40. And when the last example I did, this I think was a 2 in that first video, and so we only had to divide from one term or the other. In this case, 15 can be 3 times 5, so it can be that we end up having to divide a bit out of each of them. So we want to get whatever the biggest thing is we can divide out of each. So in this case, it's the 3. And over here, 15 and 40, that would be 5, would be the biggest thing I could divide out. And there's that extra 15 that's roaming around. So 3 goes into 15, 5x minus 6. I reduce with the 18 there. 5 goes into 15, 3x, and then plus 5 goes into 48 times. And so again, either way I get the same answer. So once you have those numbers, you can either do that method or that method, and they both work, pretty much equally well. There's a couple of spots here where, like I said, people have a little bit of trouble, but if you prefer this, then definitely do that one. I'm going to do one more example in this video, and this is where you have big numbers, but the numbers are actually a little easier. And what made this one hard, like extra hard, is not just that the 720 is big, it's that like it has a million things that multiply up to 720. So let's do one with a few big numbers but less options. So for this one I got 20x squared plus 23x minus 21. So what makes me think this one is a little bit easier is the 20 doesn't factor to as many things. It's 1 in 20, 2 in 10, and 4 in 5. And 21 is either 1 in 21 or 3 in 7. So if I think of 20 times 21, let me write that as 4 times 5 and 3 times 7. And again, it could be 2 and 10. I'm just going to start off with 4 and 5. And I'm looking for two numbers that are 23 apart. And if I kind of group these up, I could think of it as a 15 and a 28. Right there, there's 15, and then 4 times 7 would be 28. That's not it. I need them to be 23 apart, and those are too close. Let's say we tried 5 times 7, that would be 35, and 4 times 3 would be 12. So I'm just kind of regrouping these to see if I could spot the number, and 35 and 12 are 23 apart. So sometimes if there's not as many choices, if you just factor the numbers a little bit, you can see what it's going to do. If not, you can multiply those out and do like I did in the last section, or in that last question I just showed. But this is nice for, like I said, when there aren't as many choices. Sometimes if you just look at the primes, you can spot 12 and 35, and those are going to be my 23 apart. And it looks like on this one I need that 12 to be negative. So again, if I did the AC version, this will be 35x minus 12x minus 21. And I can take out a 5x, leaving me 4x plus 7. I know I'm going to get another 4x plus 7, so I'll just write that out. And that would be negative 3. Negative 3 times 4, negative 12. Negative 3 times 7, negative 21. And 4x plus 7. And 5x minus 3. Oops, not a very good 3. So, and if I do it the other way, 20x plus 35 and 20x minus 12. Biggest thing I can divide out of 20 is a 5, and 20 and 35 I can divide out of 5. And the biggest thing I can divide out of 20 and 12 would be a 4. There's that extra 20. So this would be 4x plus 7, and 4 goes into 20, 5x minus 3. So same exact answer either way. So again, whichever of those two methods you prefer, do that.